Okay, there we go. So welcome to CinJUG. We're hybrid. I'm excited to see people here and joining online. And big thank you to Trey Howard for volunteering to present. We're a friendly bunch. There's no true announcement, thanks to Caliberty for being the location sponsor and the food sponsor. And if your company wants to sponsor in the future, just give me a quick email or put a comment in the meetup.com comment section for either. And that, it's pretty inexpensive. The food sponsor, I don't know, $50 or something like that. 4 pizzas today. So that's all I got to say. We're always looking for presenters. So just reach out for that too. And I'm gonna turn it over to Trey. Thanks again, Trey, for being a presenter.
Thank you. So yeah, my name is Trey Howard, principal consultant with Pinnacle Solutions Group. I'm going to be talking about Java virtual threads. So first, I want to recap classic threads, or as they're known now, platform threads. So this is the Java lang thread that we've all known and loved, prior to JDK 19, and it wraps OS threads. So Java lang thread is one to one. Every thread is a thread at the operating system level. And it's funny for me to say expensive because, we've always talked like if you go back to the olden days, you had multi-process, which was even more expensive, like an order of magnitude more expensive than threads. So as we talk about the OS threads in this context, they're actually expensive compared to virtual threads. So it's kind of interesting, and that speaks a lot to the value of the virtual threads and kind of what they do. And the classic threads are limited by CPU cores, right? So if you start getting lots and lots of OS threads, they start competing with each other and you start running into hardware limitations. So yeah, welcome to virtual threads. Introduced new in JDK 19, went by the name Project Loom for many, many years prior to that. So JDK 19 was a short-term support. And so JDK 21 is where they became kind of final. And I think they're continuing to make improvements, in the releases since 21. So when we get our next long-term support release, it should be even further improved. So virtual threads eliminates the one-to-one relationship with the platform thread. That's kind of at its core. That's kind of its sales pitch. So it still requires a platform thread to do this to the CPU work. So that means it's not like we're eliminating Java lang threads, um, but this is a level of abstraction on top of that that makes it even easier to use. I'm not going to get too much into the syntactical differences, but it does open up some really nice, like if you're used to working with futures, there is a syntax that will give you more of a future-based interaction rather than kind of thread pools. I stick mainly with thread pools in this talk, but that is out there. Um, and key is that it does not use platform threads when waiting for other resources. So again, that gets into eliminates that one-to-one relationship. So you've got you know, these virtual threads that are just kind of, again, not using up hardware resources while waiting for things because those OS threads are really what are using the hardware. So it's managed by the JDK, not the OS. Very little overhead. So basically, they are just JVM objects, really for all intents and purposes. Second here, this. Um, so they're JVM objects, right? So you could have as many of them as you have heap space available, and they're pretty lightweight at that. It's just kind of a pointer to we'll talk about the carrier thread, kind of the hardware thread that it's on when it's actively being worked, and then just kind of some other basic, kind of code of what's being executed. Virtual threads are ideal for what I'll call legacy imperative code. So if you're trying to retrofit multi-threading into that legacy imperative-based code, it allows you to do that pretty easily without significant refactor, with notable exceptions that we'll get into later. So again, if you're working on a legacy app, this is a nice way to kind of slip this in. By the way, certainly welcome questions as we go. Um, try and keep it informal. So carry on. So this is my I'm not an artist, so this is about as good as artist you're going to get from me. So at the top level, those are your virtual threads. So again, those are JVM objects. The middle is your platform threads. So again, that's where it gets more into really interfacing with the hardware, and then at the bottom is the hardware where kind of that's where the platform threads are interacting. So what this is demonstrating is that we have 6 virtual threads with 3 platform threads available, and the 1, 3, and 6 are actively being worked. 2, 4, and 5 are waiting for a platform thread to become available so that it can then mount to that carrier. So carrier is kind of the term that's used when in the context of a virtual thread being mounted onto an OS thread to actually be worked. Otherwise, you're just kind of in that waiting state. So oh, yeah, I'll go ahead and move on. So virtual thread compatibility, thread locals, synchronized blocks, thread interruption, thread current thread. It's really compatible with pretty much everything. You get really clean stack traces. I've used this a little bit at my current client. I've been very impressed. Um, I don't think I get into this talk some of the niceties you get where you can do some fancy thread factory stuff to actually name the virtual threads so that you get like really clean logs. You know, if your logs are including the thread name, makes it crystal clear of like what that virtual thread is doing. Because as we get into the virtual thread is like an atomic thing. It's again the Java lang threads, the OS threads, and I think I'm getting ahead of myself in the presentation, but um, the OS threads or the platform threads, that's the thing that actually gets reused. The virtual tasks are very ephemeral, right? You create them, that represents a unit of work. When it's done, it gets discarded, right? And that speaks to the fact that they're just JVM objects and you don't really need to reuse them. And again, compatible with the legacy imperative, like I mentioned on the previous slide. So there's no magic. It's great at waiting. Kind of going back to that picture with the green, yellow, and hardware. Those greens at the top, again, they're just JVM objects, not using any resources. They're just waiting to be picked up or waiting for a carrier thread to become available. And this next statement is more just kind of general, concurrency programming in general. Is that it's mainly for IO bound operations. If you're doing CPU intensive stuff, like number crunching, just basic operation, kind of normal code, I'll call it, you're not going to gain much benefit out of concurrency. And it actually might be worse because you're not getting any benefit from concurrency, but you've introduced overhead by trying to do the concurrency. So it's very easy, know when you need to use concurrency. And and again, if it's IO bound, it's almost certainly it's a candidate and very likely to be benefit from concurrency. So the responsibilities. So your OS threads, again, the platform threads are responsible for scheduling the platform threads. The JDK is responsible for scheduling the virtual threads to be loaded onto the platform threads. And so these steps here are kind of that mechanism, right? JDK mounts the virtual thread on the platform thread. That thread becomes the carrier. Again, that's that context there. Carrier is the name for what the virtual thread is, which platform thread it's using. And that is invisible to the app code. There's nothing that exposes it unless you like, if you put a debug breakpoint in, you can't actually dig in and like see that private data, but it doesn't show up in like toString or there's no getters or anything like that. Then the OS schedule, carries the thread as usual. So right, that's kind of your normal Java lang behavior that again we know and love prior to JDK 19. And then when it's done, the JDK unmounts that virtual thread from the platform thread, which frees up that platform thread from, it frees it up to then take on the next virtual task or virtual thread. So, all right. So, scheduling. So this is where the code blocks. Actually, trying to remember what I was. This is bad. I don't remember exactly what the first bullet point's referring to. I'll skip over it. I guess the code block on input output, data structure. Then the virtual thread unmounts, and time goes by as that operation is being worked. If it's a blocking call, it will return. Um, I'm not worded this very well, but the it in other languages it might be called yielding. So you would actually yield the platform thread, which would allow something else to then work concurrently while the other thing kind of finished that blocking operation. Um, and then so when the blocking call returns, it then submits that the virtual thread to the scheduler. So again, that's the platform thread. taking on the new virtual thread, it gets mounted and resumes. Unmounting limitations. So there are some, concurrency or multi-threaded, it's actually more multi-threaded, I would say, scenarios that um, basically prevent you from doing that unmount on a block. So again, when I say blocking, I'm referring to like an IO wait, that sort of thing. So like if you're making an API call, you can let that be running in the background while, picking up some new work to be done. There are certain operations that will not allow you to free up that Java lang thread, that platform thread. So if it's a blocking operation that doesn't unmount, so there are like as mentioned here, like limitations of file. So if you're using OS files, which is not there's the newer NIO file stuff. That's some of the non-blocking IO, so that will benefit from unmounting. But if you're using kind of the old school um, files, those will prevent the virtual thread from unmounting and JDK wait or object that wait, thread that wait is another one. And this is compensated by expanding the scheduler. So again, that's kind of a balance that you need to strike, kind of a your mileage may vary situation. Pinning, this is another biggie. So again, usually it would unmount an operation, um, but in this case, it prevents it. So this can be caused by native method or foreign functions, synchronized blocks, again, stuff that like you can give me into semaphores just in general. Anything that in multi-threaded programming that you're actually kind of blocking an operation, it's going to have the effect of it's not going to free up that thread because it needs to maintain it to ensure consistent behavior with that again kind of that blocking operation. And of course, native methods, that's kind of an unknown to it, so it has to hold on to it out of defensively. In some cases, dare I say most cases, you can make code changes to work around that. Um, I think I've got a screenshot of some code later in the slide in the deck where it shows how you could replace I think it's a synchronized block with there's a semaphore that is sort of virtual thread compatible or works a little bit better that to mitigate that to at least give you a little more flexibility. We talked about capture and pinning. Um, does not impact program correctness. It the unmounting certainly can hinder scalability. So again, that's where if you run into those scenarios, can certainly if you can look at it and say, are there again, if you're trying to lay this on top of existing code, are there some minimal code changes that you could do that would still allow you to benefit from the virtual threads? And again, the JDK team they're going to continue to improve this moving forward. And so I would like to see, kind of selfishly here, I'd like to see some improvements made, kind of like the special semaphore, where there's things that they can introduce to allow you to work around the limitations or at least mitigate the limitations. So again, we'll see what they do. I've not been tracking that work, partly because if something gets introduced in a short-term release, it's not guaranteed to be in the next, um, or in the next long term, I should say. So I'm kind of holding out, waiting for the long term to see what they actually settle on. So the sweet spot, imperative code. Again, this speaks to the legacy stuff. Um, this is not a fit for JDK8 streams. So if you think about like the JDK8 streams, like the parallel things like that, those are very different. Completable futures are in a sense like a competitor to virtual threads. So the completable future, like you kind of want to rewrite it to not be a completable future in order to benefit from virtual threads. Um, the and then other things that are not a fit, like those familiar with reactive programming, like Webflux, those have already solved the async in a different way. And so again, virtual threads are not going to benefit much there because those frameworks are already providing that functionality. You get cleaner stack traces than streams. That's just a little shout out for, if you're thinking about like a stream parallel versus doing something with virtual threads, you will get cleaner stack traces. So just some practical advice and kind of the work I've done with it. Do not pull virtual threads. As I said, let the virtual thread be a unit of work and you throw it away when it's done. Create a new virtual thread to represent a different unit of work. Pooling is ideal for expensive resources. Again, virtual threads are cheap. I've forgot to put a code snippet in here, so there's an embarrassing to do in there. So this is using the semaphore instead of thread pool. I think I've actually got that screenshot in here, so not a full face palm there, and avoids the expensive platform thread, right? Minimal platform threads and then many virtual threads, and let them mount as available. There's a term in multi-threaded, so it's a blend of the words thread and thrashing, which is threshing. So if you have too many platform threads going on, it's called threshing, where you're spending so much time switching between the threads that it introduces a significant overhead of like kind of lost throughput. Um, and in extreme cases, you actually end up with worse throughput than if you weren't using multi-threading at all. And that kind of goes back to that point. If you're doing kind of more CPU bound operations, that's absolutely the case where you're not getting much boost from the concurrency to begin with, and then you're introducing overhead of trying to switch between those. So again, that speaks to sort of the old world where we had to do many platform threads, again, those Java lang threads, that if you get lots of those, you end up in that threshing situation, and it's where you get a lot of inefficiency. So sequential access, again, I think I've got that screenshot of the reentrant lock later. And this avoids pinning. So the reentrant lock is that is that special semaphore that will allow you to kind of retrofit. And then reconsider local threads. The local threads have a much higher overhead. Um, if you have, I'm trying to say this right. So the memory footprint due to many virtual threads, it's thread locals, they work a little weird. They're compatible, but you kind of have to know what you're doing. I'll give a little warning on that. And so again, this is just kind of the practical advice. If you're using a local thread and you want to leverage the virtual threads, you may want to reconsider like either the way you're using local thread or even if you need the local thread at all, kind of with the new approach. So all right, here's my screenshots. So again, at the top, we're seeing kind of the old school way. We don't want to do that. So this is executors kind of showing a database query. And on the bottom, we've got the semaphore that shows how you're doing explicit semaphore acquires and releases, which is virtual thread compatible. And so in this case, you could actually execute up to 16 concurrent. The semaphore was created with 16. So again, this is demonstrating this is one of those workarounds for the limitations. Leave this up here for just another moment in case people are reading the code, and I'll move on. All right, here's our next one. So this is a synchronized block. Again, this is another one that's kind of our bad actor in the virtual thread world. So we replaced that with a reentrant lock, and so the reentrant lock um, guarantees that sequential access so that we can then, the virtual threads can benefit by being able to mount and unmount. Whereas the synchronized would have that virtual thread pinning that platform thread until the entire thing completed. Um, so I'll leave this up here for just a moment so folks can read the code. All right. So in the future, I think most programs are going to really embrace virtual threads and reduce the platform threads in favor of virtual threads, because I think they'll see increased throughput. Um, yeah, I have hopes that the web servers or the app servers out there will start doing this. And again, maybe it's still configurable. Maybe there's a way to tell it I still want to use platform threads for some reason, but kind of driving people in that direction. So I'm again an optimist, to a fault. So when I first gave this presentation, I said like 3 to 5 years. I'm trying to bring it down to 2 to 3. I mean, it takes a while. It's just, I mean, JDK 1 or say JDK 21 has only been out for like a year or two. So it's going to take time for the tooling out there, your app servers, your frameworks, things like that, to really start embracing it. Um, but again, I'm perpetual optimist. I'll hope that happens. Just a quick reminder on the JDK releases. So you get a short-term release every 6 months, and then every 3 years you get a long-term support. I just realized the numbers aren't quite matching up there, so maybe they've changed that a little bit since I since I left put this together. Um, so the JDK 9 that came out in September of whatever year that was when that was with the partial, that was like your short term, and then when JDK 21 came out, that's what made it final. Um, yeah, just a quick anecdote, not related to multi-threading, but um, in somewhere between the 17 and 21, there was a feature that was introduced that I was really looking forward to in Java, which was I forget the fancy name, but you can do like variables within the string. Like $sign curly. .NET, a lot of other languages had this for years, and I was really looking forward to Java have it. They introduced it in, I don't know, like 18, 19 timeframe, and it actually got removed before you got to 21. So I found some page out there after our project upgraded to 21. I was like, great, I can start using that. And I put it in and nothing, it's like not accepting. What the heck? And after a little bit of Googling, I found that it got removed before 21. So Java still does not have interpolated strings. I think that may be the name. So Java still does not have string interpolation, which is just a nice little syntactical sugar instead of string concat or string formatted. Anyhow, so that's all I got. I went kind of fast. I'm happy to go back and review anything if anybody has questions.
Let's look at the comment real quick in the chat. It says Spring and Tomcat already support virtual threads. All right, very cool.
Fantastic. My optimism has paid off.
Hey Trey, have you done any like lightweight performance testing between, normal threads and virtual threads?
I did kind of like some Hello World type performance testing. Actually, I did a little more intensive at a client. So the Hello World type testing that I did was taking. I think I took um, I did a pool and tossed out. I think I was doing maybe like 10 tasks at a time, and threw maybe like 1,000 at it. Just doing thread sleeps, right? The thread sleep is kind of a little dummy. It's kind of the old classic of simulating work. And I saw that the overhead, so like again, the timings come out as like a second plus whatever. And so that plus whatever is the overhead that you're getting from the concurrency itself. And I mean, it was pretty dramatic. I mean, this isn't going to sound dramatic when I say that it dropped from like you know, like 0.12 seconds down to like 0.03. That may not sound like a lot, but when you talk about, kind of at scale, that's what, like a 4 times improvement. And that's just purely the overhead aspect, right? As opposed to doing, spinning up 1,000 threads or rather a fixed thread pool that's processing so much at a time, that sort of thing. So on that note, um, the um, the the way again in my clients the work is usually done with thread pools when doing concurrency. There is a like a straight drop-in replacement for the thread pools. There's a new method in the executor service, the factory methods that create the thread pools, and it's called new virtual task per something per new virtual thread per task or something like that. And what I like about it, it's kind of the blend of both worlds. So again, in the old world, you had fixed thread pools, and I forget what the other one was called, but basically one was you didn't have anything fixed, but it would grow as needed, but it would grow unbounded, right? So you were at risk that if you had some big spike, you might actually create more OS threads than were available. On Mac and Linux, that's usually around 1,000, unless things have improved significantly since I last checked. On Windows, I don't think there's a hard limit, but your machine will become unusably slow. And I can attest by experience there. I'm running on Windows. I did actually do that once. It's unpleasant. Um, so, in that sense, so your fixed thread is you're using resources even if you're not actually running anything. The other one runs that risk of running out of threads. Also, it's not even like when things crash, but like when you get into maybe the hundreds of threads, you're going to notice some performance loss, that threshing that we talked about. Whereas in the new method, you gain the benefits of the kind of the growing, so it'll grow unbounded. However, it's growing unbounded on JVM objects, right? So you're not threatening hardware resources with that, and you're also not using resources when it's unavailable. I should take that back.
Fun.
Depending on whether you want to use a dedicated thread pool or to run the virtual threads, or if you just want to use the default fork join pool, which is very common if you're just doing kind of ad hoc stuff. So I think I answered your question there, maybe a bit more. Um,
Yeah, no, that answered it well. Thank you.
yep.
I was trying to turn my laptop so you can see everybody in the room, but we got a question coming in from chat. This is perfect. Here's the question. Do you think there is an intention to deprecate platform threads at some point?
Um, I think it's always going to be a necessary evil because you have to have something outside the JVM that's really interfacing with the hardware. Um, I'd be intrigued. I mean, the folks out at Oracle are pretty sharp. Maybe they can think of a way to work around that, but I would see it as a necessary evil.
I got you. How about questions from the room? Anybody got any questions from the room? Dan Miller's got a question.
Can you hear me, Trey?
Yep.
Okay. You mentioned that as part of setting up the virtual threads that you set up a platform thread, and then after that's done, it's kind of the code doesn't really know about the behind the scenes of it. Is it pretty straightforward to like set that up and assign the virtual threads to a platform thread? Is that
Yeah. So if I remember here, it's been a little while since I've looked at the precise code, the syntax of it, but I believe the virtual threads can specify sort of a pool. So again, you're not telling it a specific thread to use. Although I think the alternate syntax that I talked about, like with the futures, that one you may get a little more precise. But when you get into the pooling stuff, the it you're telling it what thread pool to use. But I think what I was referring to with the not exposing the carrier thread is that is a very internal like implementation detail, and they kind of don't want you to know it because they don't want you to build any dependencies on it because they may want to change that in the future. Um, did that answer your question?
yeah? Thanks.
Okay.
You don't have to set it up. The JDK does it. It's all built into the JDK.
Okay.
Was there another question in the back, or was somebody waiting?
I was waving high, sorry, because we got.
All right.
How does stack size differ between platform threads and virtual threads? I'm assuming significantly less. Any downsides to this?
X. I'm not sure. That's a good question. I don't know.
So what
I
the
I
benefit
do know there's something I'm not remembering a lot of specifics, but just in that realm of kind of stacks. I think this might be the thread locals I'm thinking of. Your virtual threads are able to see the thread local, and you get kind of some access to it, but it's some strange access. And I think that's where the slide where I was talking about where you may want to rethink the thread local is that you end up with a lot of overhead that each virtual thread ends up with kind of its own copy of thread local stuff. And that's where you start to lose some of the benefits of scalability, um, of the virtual threads. So that wasn't maybe necessarily the question, but maybe a corollary.
We had a comment in the back. James, you want to?
I don't know if they can hear me. Can they hear me online?
Can you guys hear James online? You can come up here if you want.
Yeah, I could barely hear him.
I asked him to come up. I did. We do have microphones here. I just didn't hook them up because I'm.
So the stack trace thing is so what they usually do is like if you think about a typical stack trace where you're going all the way down, let's Spring Boot, your stack traces go all the way down into like, hey, let's spin up Tomcat. The virtual thread stack traces stop wherever you started the virtual thread. So you don't have that dangling list of everything that's going on in the entire JVM. You don't need that. It just says, okay, you started a virtual thread. So they're really only 5, 6, 7, 8 lines long. Typically, they're not terrible. Got the mic plugged in.
Yeah. Thanks, James. I realize now that I misunderstood the question. I thought it was stacked frames was being asked, and that was definitely something. Any other questions? All right. Well, thank you.
Thank you, Trey. Appreciate you presenting. A very friendly crowd. We do have time left over. If there's any more questions or if anybody wants to chat about anything, we could stop sharing the screen and chat about any JVM, Java, software development related topics. We got a lot of experienced uh, software developers and architects. So, hey, Mary, welcome. And welcome to everybody that else that joined a little bit after we kicked off.
Thank you. Sorry, I was working on some things I forgot. It's Eastern time and I'm in Central time. So sorry.
Hey, it's
Okay.
no
Yeah.
big deal. Everybody's welcome. And
Yeah.
surely somebody has some questions.
Cool.
Oh, here we go. We got a question.
So assuming I'm working in a frame.
I can't hear.
Okay, I'm sorry. Can you hear me now if I speak up?
Yeah, that's better.
I don't mind speaking loud. I said, assuming I'm working in a framework like Spring, which is encapsulating all this for me, if I were trying to troubleshoot something like with the threads, is there something that can allow me to have sort of an open box look at what's going on behind the scenes?
What I would say is that again, I'm speaking from experience here that I've done with coding, is that you're still being very explicit about the use of concurrency. So Spring isn't doing anything automatically for you. You know, you're gonna have, you know, like a thread pool, for example. You're still going to declare your thread pool, or you're going to instantiate it within the method or whatever. So Spring is not providing that automatic, if I understand the question.
I think so. Yeah, I think you understand. Thank you.
Yeah, in which case you'd have full visibility to it because it's, again, there's no magic.
For those online, feel free to unmute and ask or whatnot, and or you can throw it in the chat. Here's a good question. Has anybody used these in production? Anybody online? Anybody in the room? Oh, we got one person in the room. What about on the virtual Zoom? Anybody use these in real life?
Unfortunately, I have not. We've got some kind of pre-virtual thread concurrency right now that I have hopes to switch to virtual threads in the near future. But we have not yet done it, so I can't say it's in prod.
Gotcha. How about you, James? Where'd you use them in prod?
So we use virtual threads internally. We have a tool internally called Kali. I will warn, if you're in an environment where it's like CPU restricted, so inside Kubernetes, when you ask how many CPUs do I have available to me, and it says a low number, that number dictates by default how many carrier threads you get. So it's going to only allocate one carrier thread per CPU that you have access to, or per core. You have to kind of trick it a little bit in a virtualized like Kubernetes environment and tell it that it has more so that you can leverage it. Otherwise, Tomcat does get a little confused, so to speak, and it'll only spin up one thread for your virtual thread, one carrier thread for your virtual threads.
It's a good call out.
Yeah, appreciate that.
Well, and James just brought up, so anyone that's using Java 21 with Tomcat will be using this by default.
Not by default. You have to do spring.threads.virtual enabled equal true. But it's
Yes.
very easy to turn on.
Yes.
Yes.
All right, I guess I take back my earlier statement for the person in the back. I guess Spring will do some stuff automatically for you.
Yeah, Tomcat runs all your requests in virtual threads when you turn that property on in Spring Boot.
Okay.
Very cool.
And I love that Trey pointed out the semaphore thing. If you think about like how, as he was saying, these things are very lightweight. You can run millions of them. The semaphore is useful for if you have downstream services that you were calling, let's say some web service or something. If you can spin up millions of virtual threads at a time, and those would be calling downstream services, that's not good, right? That's not good for that downstream service. So you can kind of use those semaphores to throttle your access to those downstream services so you don't overwhelm them. That's one little trick. And it's a gotcha, right, for virtual threads because it doesn't behave exactly like regular threads. It's starting an IO call, parking that off to the side, unmounting it from the carrier thread, and then getting another one. So you could have an in-flight request to this downstream service in tens of thousands at a time, and it can be really bad.
So James, I'm curious. You mentioned that you had intended to do a virtual thread talk before and weren't able to. How much of what I covered would have been in your presentation?
Definitely, you covered a lot of the same stuff for sure. I did do some benchmarks. I still have those screenshots. I don't know what happened. My presentation got corrupted. I don't know. I have like half of it. Mary was there. She saw me do it. There's a video of me doing it, so I'm not BSing here. It was fun. It was a good talk. But I do have some screenshots of like my benchmarking, and I'd be happy to share that. There was some kind of really cool illustration of what the benefit actually is. So happy to do that if you'd like.
Yeah, if you want to share your screen, you got
That's
it.
why I asked for the Zoom.
Oh, cool beans. Awesome. Yeah, James, if you got them, share them out.
And
Go ahead, Mary.
FYI, yes, sorry.
No.
FYI, our Chicago Java users group, we did a recording, right, of James' talk too. So I can share that YouTube link if anybody are interested. So
Yeah, definitely.
Yeah, that'd be great if you threw it in the chat.
yeah, let me do that. Yeah. Chicago.
I'm no artist either, but my illustrations of those carrier and virtual threads weren't much better. That's for sure. Very blocky. I have to like accept to go to the meeting to get the Zoom. Can you?
I said, really?
Did you send it to me somewhere?
Yeah, it's on Slack.
Oh, sorry.
Yeah,
Yeah, got it. Never mind.
Yeah, I just share that link. So
Got
Thanks,
it.
Mary.
Thank you.
on the chat, yeah, you're welcome. So.
So I don't know if
Very clever title for your talk, James. So as a reminder, Project Loom was the what virtual threads were known as before. So his title of his is Fruit of the Loom.
Yes, yes.
Yep.
I
Very
did
nice.
wear more than Fruit of the Loom for the talk, so don't worry about that. I had more clothes on than that. So this was a illustration. I did a performance test using Gatling, and this was, if I was just using platform threads, this was a very simple, like I was illustrating, like there is some wait time in here. I put like a thread.sleep or something. I have a GitHub that you can play with this if you want. But this is with regular old platform threads. So they are, you can see as you start to scale up, that top picture is the kind of the percentiles of how long it's taking for the request to finish and the throughput and that sort of stuff. So you can see it starts to go a little crazy up there around, oh, I don't know, 2 minutes in, it starts to go a little crazy. And then on the next slide, you can see things are a lot more uniform. It's the exact same number of requests, exact type of requests. All I did was turn on Java virtual threads in Spring Boot. That's all I did was flip that flag. And what's happening here is you're actually able to leverage more of the CPU. So when you have a platform thread that's waiting on some IO, yes, it will time slice and then another platform thread will take over and do things. But with virtual threads, you're not having to give up the CPU as much. You can actually leverage and use more of the CPU. So just with turning on that flag, I was able to get much more throughput and a lot more stability. As Trey said, you're not going to get computation. It's not a magic, bullet. It's not going to be this lightning in a bottle for computation. You're not going to turn it into a quantum computer, but you are going to be able to use more of the CPU because you're able to without having to do anything, because you're doing asynchronous programming without having to do it yourself. This blew me away. I thought this was cool. When I saw this, I was like, wow.
Dramatic.
Mm-hmm.
There was a question in the chat.
didn't
Can
see
you? No. Thank you. If you could take a quick peek at it.
You sent the truth, but I just put it in.
Yeah, it's like spring.html threads.virtual.enabled, I think, or
In the
something.
chat, yeah, okay,
Oh, is that what that is? Thank you.
yes,
Yeah.
Yeah, thank you.
Then we switch.
Awesome.
So I can use, there's the production case, or the case where we do this in production of my current client. It's a batch process, and it's kind of it's like an ETL job is the best way to describe it. But it's an ETL of API calls, multiple queries, things like that. And so we fire all those on threads so that they're all going in parallel. Like some of the queries are a few seconds. Some of the API calls can be a few seconds. So it's kind of death by a thousand paper cuts if we were to do it all sequentially. And so that's one of the cases where I'm hoping to switch it to virtual threads. Honestly, just kind of as a swap in, right? Drop in the virtual thread per task rather than a fixed thread pool, so that it'll fly, right? It'll maximize less overhead. Going back to the informal benchmark that I did with the Hello World stuff, where there's just less time spent switching threads because you're switching. The JDK is more efficient with swapping, with mounting and unmounting the virtual threads.
There's a couple of new, and I don't have the slides, but there's a couple of new utilities that they're introducing. I don't think they're
I think somebody's playing the YouTube video, not on mute.
Can you hear me?
Can you hear us?
Can you hear me?
Maybe. You guys hear the room? No? Hello?
Shamal.
Oh, sorry, that was me. I don't know how that started in the background. But... All right. So, so yeah, the JVM is much more efficient with mounting, unmounting to platform threads than, the platform threads like switching in the old Java Lang IO world, right? Like, so that's where it's just, you get more throughput, and that's a very simple, very niche use case for it. But kind of swap it in instead of the old school threads and just get a boost because it's more efficient with switching.
Yeah, also that I asked about what would be the benefits other than SQL. That would be one of your services on the back end, but just think if you had some other service you were calling that rendered some object or something that there was some overhead, then that particular thread would get unmounted. So you wouldn't have to, you either wouldn't saturate or have to scale if you're in a container, environment, because you get you're not going to use up all your threads potentially as soon, put it that way. Need to scale or saturate your client service, shall we say, is because I think that's what you're alluding to. Would
A word
that
of caution
be?
that I'll have regarding the SQL, and we ran into this pretty quickly, and it was kind of a facepalm what we did. So a lot of applications use connection pools, and so it's very easy. You're not going to bypass your connection pool limit just because you throw more virtual threads at it. So you might end up kind of throttling yourself at the connection pool level if you've got a lot of queries running in parallel. And that's not a virtual thread thing. That's just kind of a concurrency thing.
Very similar when people try to build caches on top of caches.
Yep.
It
honestly reminds me, James was making the point about, doing semaphores to limit that impact of the downstream stuff. Same concept, right? You can easily overload your database if you throw hundreds of queries at it at a time.
Right.
An object pool is a semaphore. You're just borrowing the objects, not tickets from the semaphore. It's the same concept, right?
Yeah, great point.
Yeah, but if you
a couple of utilities that I wanted to shout out that are really cool that I don't have the slides on this one because those are ones that I lost, but there's structured concurrency. So this is designed for virtual threads, so you don't have to do, like Trey was saying, the all of the completable futures and all that stuff. It makes it very, very easy to consume these virtual threads and spawn things off and do like kind of scatter gather pattern. So you can spin off a bunch of tasks and you can tell the structured concurrency, okay, when it's done, wait for everything to be done. And then I can just call little getters on each one of the tasks that I spun off. And they're not asynchronous things, so it doesn't throw all these crazy exceptions that you have to catch. The other is directly related to what you said about thread locals. They've recognized the problem as you were talking about, and it's not just for virtual threads, but it does help. It's called scoped values, I believe is the name of it. So you basically create a variable, and when you want to call some other stuff that has access to that variable with a value, you kind of bind the value to the scope variable, and then you go call the other stuff. And anytime inside that stuff, it says, hey, value, you know, or what's the value of the scope variable? It returns exactly what you said. So it's a little more explicit control, I guess. But it does clean itself up better than the thread locals. Those are new, and they're not fully released yet. They're preview still.
And those are like libraries, or is that something the JDK's built in?
It'll be part of the language when they're fully released. Yeah, it's
Fantastic.
Yeah, it's structured concurrency and scope value. You can see them. There's a ton of articles out there about them, but it's at the end of my talk. If you fast forward to the end, I talk about it. That did make programming with the virtual threads really easy, especially if you're doing like a scatter gather thing.
Something sure to watch for though, I wouldn't necessarily use the semaphore where you have your database calls in there, because you could end up potentially disrupting your locks if you have locking going on. So you'll get a deadlock.
Can you
So
say that again,
if you
Carvin?
start having, by you handling semaphores with anything that's also making database calls through the connection pool, you're going to disrupt anything that, or potentially disrupt whatever your JPA library has with respect to helping with deadlocks. Above and beyond what you should still be doing on yourself.
Yeah, good call out.
Yeah. So just sort of something also to keep in mind, because you could start debugging and seeing that, and oh my goodness, I got away with this before until my load got to whatever point that might be. And my database grew in such a fashion that I now am introducing locking or more locking where I did not before. But these are some pretty common scenarios one ends up with as their environment grows.
This was my crude artwork, Trey, for mounting.
I like it. Yeah, I like it.
I'm not an artist either. So.
Okay, your colors match.
Yeah.
And there's contrast to them.
Yeah, the idea was the big fat arrows are those platform threads to illustrate how much more heavyweight they are. Anyway.
Is that in your that slide deck in your GitHub?
No, as it got corrupted, I would love to be able to share it with you, but the thing, I don't know what happened. I've never had that happen with PowerPoint in my entire life. But I opened it up the day of the presentation for CinJUG, and most of my slides are missing. As you'll see if you watch the video, there's a lot more slides than what you saw on that screen. So I was not happy.
At least you got video of them. You could recreate them.
Yeah, and I have some of the harder ones that were to create, but there were some other ones that were they took me a while.
All the animated kits.
Yeah.
The memes, cat videos.
Yeah, ask AI to create those based on the presentation.
I bet.
Slide. See if it can do that.
That's not a bad idea. That is not a bad idea at all.
Maybe use Sora, that OpenAI's model, right?
All right,
video.
I'm gonna try that.
Yeah.
Yeah.
Yeah, it should. Microsoft's involved with it, so it should be able to do it. Recreate my lost PowerPoint.
I want my money back.
Yes, or send me a refund.
Yeah. Yeah.
There's a chat. You can check
That was
out. I think.
that was Marshall. He said just use it and it.
Little trollery.
Uh-huh. Thanks, Marshall.
Nice.
I think one of the unsung benefits that people, I don't think enough people like that they point out with this, and I don't even know that I did it enough justice. The idea here is this, again, this is not, we've been able to do asynchronous programming for a long time in Java. With virtual threads, you don't have to. Your code is so much simpler. You can just do normal code. It just looks like regular old code, and you don't have to explicitly say, oh, go off and spawn another thread or whatever. And I'm going to be waiting on this IO, so come back and call back to me when it's done. It does all of that automatically underneath the covers. It is doing it for you, so you can write regular code. You can go so much faster. I don't know if anybody's ever done web flux or any of those things, but once you start pulling that thread, so to speak, you have to go async all the way down in order to get all the benefits. Otherwise, you're just fooling yourself. With virtual threads, you don't have to worry about any of that. It automatically parks and unparks things for you, and it can clean up your code and make things much faster and still give you the access to the full CPU.
Yeah, nobody asked in this call, but previous time I gave this presentation, someone asked virtual threads compared with Kotlin coroutines, and they are different things. So like, different in the sense that in theory you could actually run virtual threads, like multiple virtual threads within a coroutine. So that was kind of interesting. So thought I'd share that here for any Kotlin folks.
How about, I'm curious too, now that James brought up about async, and then Akka model, or Akka is using actor model. So how does actor model, right, work with virtual threads, right? That's some question I've been trying to find answers for too. Just wondering if you look into that.
That for Trey or
Yeah,
for
James, I remember James, you gave a talk several years back on Akka.
Akka, yeah.
Yeah, I think you nailed it, Trey, that like if you already have asynchronous code, if it's already doing all the callback stuff, which is what Akka is doing automatically behind the scenes underneath the covers, you don't need to use virtual threads. It's really not going to benefit much from it at all. So as far as all of the delivering messages to the actors and all that, they're already doing all of that, and they've optimized that to the utmost. It may even be more performant. I don't know. It's close, right? You get like 95% of the way there without having to do any asynchronous callback hell programming.
Yeah.
But I would imagine Akka is highly, highly optimized. It's been around for a while. They probably don't use it at all. They probably wouldn't benefit.
That's right. Yeah. Cool.
All right, any more comments, questions?
Of course, I'm sitting back here trying to make this all about me, so I'm trying to put it into how am I going to use this? I write web services for a Great American in REST and web client and React and with Spring Boot 3 point something, and it sounds like I can turn it. So we have low users right now, but it sounds like if I have problems, I can turn that switch on. And if I wanted to, that my glass box thing I was asking about, I could go into my REST template and look at the thread factory and find out what threads things are running on, right? If I was a sloppy programmer, I'd just put logs in on what those thread IDs were, and then I'd see in my log all these threads being created. Does that sound right, or am I off the
Yeah, for most people, that's probably the beauty. That's actually how I got into Java, was thread stuff, because threads are not easy. shall we say. I mean, I came over from a C, and even the old C and C++ people, especially in the Microsoft world, they didn't really understand threading.
Yeah.
And well, I don't know, Anthem still uses the stuff that I did for them. Do they need to? No, not anymore. It's gotten simpler for them. I mean, it was a very specific use case. And so I would say, yeah, turn on your framework's going to take your springs, and your various frameworks are going to take care of most of it behind the scenes for you. In fact, even some of them, back in when we had the JE2EE spec, even with servlets and that, and I don't know if the spec has changed. They really tell you to refrain from doing threading unless you need to, because it's supposed to be handled within those specs themselves underneath the hood, the engines that you get, or the implementation of those engines to those specs. So
One
you should
thing,
just be a benefactor.
yeah, I think you're right, Gartman. Now, if your web clients are, if you're using all the async stuff, if you're not too far along, I would say you can throw that away. All the async can go away. You can use the blocking versions of all those calls, the web client call. You don't need an executor, because every single request thread is a virtual thread. If you turn on that flag, yeah. But if you're handing an executor service, as Trey said, they've got kind of a retrofit for it. They have an executor that does virtual threads. It doesn't use real threads. It makes it look just like the old stuff, and that's the best way. That's actually how Tomcat does it, right? They don't set up the executor service with 20 threads. They say executor service dot whatever new virtual thread per task executor or something like that. That's
Yeah, I found my code project, so I can share my screen since we have some extra time.
good.
Sure.
So hopefully, can you guys see that?
Mhm.
All right. So again, this is the little hello world thing. So this is old school using a fixed thread pool. So this is again old school new fixed thread pool. You give it the size. So this is the downside of using resources, whether you're fully utilizing or not. So I'll run this, and these are just thread sleeps. This is done with a supply sync with a sleep counter. And so if I make this a little bigger. Oh, I think I left this as a lot of threads running 16 at a time. So hopefully this doesn't take too long. I think this was on a demo where somebody said, "Hey, what happens if you turn it up to?" Yeah, that's a big number. Let's bring that down to 1,000 so we can finish it today. Here we go. Um, why is that not? Well, maybe I'm not going to be able to demo this anyhow. I don't know why it didn't stop at 1,000. Well, I guess I'll focus on just the syntax. So if I go to, so here's the cache thread pool. That's the one that grows unbounded. So this is where you're not specifying a size, but this will grow unbounded, again, threatening the hardware. So those are the two kind of old school ones. And then in the virtual thread world, this. Here's the new virtual thread per task executor. So James, you got that name right. So again, straight drop in looks like the cached one, but it again, you're going to get that benefit of like you're not threatening hardware, right? And then here's this is the same thing using this is that thread factory I talked about. So this is where you can give custom names to your virtual thread. This is like in my use case at my client where it's a batch process. It's just running a bunch of stuff in parallel. What was the term you used? Separate and aggregate. I know James, you had a cool little phrase there I hadn't heard before.
What did I say? I have fork join stuck in my head, but
Scatter
gather. Yeah.
Scatter gather, that was it.
Yeah.
So this is like scatter gather, but you can name the virtual thread to what it's doing. So then your logs, you can actually see that thread name to kind of correlate of, oh, like I'm operating, I'm doing this operation on behalf of plan number X, or whatever. Kind of cool stuff. And then, yeah, this was synchronized. This is showing that, you lose the benefits of the virtual threads if you put so that in this case, the supplier put a synchronized block in. And so this is where you'll see it doesn't free up the platform thread at the end of every one. And so it ends up being super slow. So unfortunately, my number of tasks here did not kick in the way that I wanted. So try this again.
And there are system properties you can set to tell it to like log whenever it gets pinned, and you see pinning, you can tell it to spit out a log. That helps you to know if you have anything where it's not going to be compatible with virtual threads, because it'll log and say, I'm being pinned to this carrier thread right now because you're using synchronized. I actually submitted a bug to Spring because there was one of their libraries that was getting pinned. I was able to see it in the logs. So anytime you have that, as Trey was saying, you got to go in there and substitute out some sort of a locking mechanism, because they've injected little hooks. Every time you call lock, it says, okay, try to get away back to the carrier thread because I'm going to be waiting on this lock for a little bit. All those have been already injected into all the code. If you look at the PR for Project Loom, it's thousands of files. They have sprinkled these little give back the carrier thread everywhere, all over the code. There's all these, like, it's basically doing the whole what was it? What did you say it was? What's the name for it when you're giving it back? The yield of all those yield calls are sprinkled everywhere in the the JVM code now. And I shared the structured concurrency and the scope values thing from my repo. If you wanted to look at that, that was kind of cool. I thought that was really nice to save some keystrokes there and make things easy to use.
Nice.
I mean, I can share it if you want.
Go for it.
See, where's it at? Yeah, so this is, as I was saying, like the idea here is this. You guys see that?
Yep.
So there you're defining that account number. So it's kind of like a global variable, but it won't have a value until you do this run where thing. So you're basically saying run a bunch of stuff underneath this as kind of a closure of sorts, right? And then within there, the account number variable is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and once you exit from there, it gets cleaned up. So you don't have that problem with virtual threads of that binding and that memory leak thing. That's the same. Did you say that's the same combination you have on your luggage, Mark?
It is indeed. I don't know how you did that. It's uncanny.
Yeah. We've been working together a while. And then the structured task is below that, right? So this is the, if you want to just spin off virtual threads, you can spin them off and go do things automatically, and it'll happen within this scope thing, this structured task scope. And it'll automatically wait for everybody to finish by doing that little line there. Again, I don't think these, even in 23 and 24, are they going to be fully, I think you have to turn on like experimental features or whatever to get this to actually work. Yeah, this is a little better example. So when you fork these things off, they just hand you back a supplier, right? So instead of like a future where you have to like catch exceptions and all this stuff and worry about is it here yet or not, you just fork them off and you get these suppliers back. So you can call customer.get. That's all you have to do. It's just a regular old supplier. It's actually a subclass that has more things, but you can just treat them as just suppliers.
Pretty cool.
I do have a fun dining philosophers example with virtual threads in that repo. That was fun to get working. So you can run the dining philosophers problem with one thread, one carrier thread, and it just illustrates that it actually works. Everybody can get fed. Everybody familiar with dining philosophers? I said that without like any context. So the idea of the dining philosopher's problem, it's a concurrency illustration. So you have 5 philosophers sitting around a table, and there's a fork in between each one of them. And in order for them, so they'll think for a little bit. That's why they're philosophers. They think for a little bit, and then they have to pick up the left fork, pick up the right fork, and then they can eat. And then they'll put down this fork, put down this fork, and then they think some more. So they're all sitting around and they're trying to eat together. But if I pick up both my forks and somebody else is sitting here trying to pick up the fork, they're not going to have the one to their left, right? So it's a coordination problem. It's just an illustration of how you do these sort of coordination among threads. And this it illustrates deadlock. You can get into a deadlock scenario with the philosophers if you don't do it right. But that code example does have a dining philosophers example for you. If you want to play with it. Anything else?
I don't have anything. Anybody have any other questions or concerns? All right, I think we'll wrap up then. Thank you, Trey. Thank you,
Thank
the
you.
rest, everybody else that showed up in virtual or in real life. It was awesome. I look forward to hybrid meetings from this point on, and just keep an eye on the meetup.com. And if anybody wants to present, just reach out. We're a friendly crowd, and I don't know, I pretty much bless just about any topic. So as long as it's related to software development for the most part. So all right, thanks everyone. Have a good rest of your day.
Thanks.
Thank you.